speaker today will tell us a little more about the rocket itself. Dr. Scott N.A.S.A is with the United Launch Alliance program, program operations for NASA Launch Services. In 1992, he joined the Boeing company where he worked on various research and development projects, and he was the engineering lead for the development of a new second stage for the Delta II, upper stage for the Delta II. In 2000, he was appointed the program manager of the NASA Launch Services program, where he worked closely with NASA and various spacecraft builders to launch the Phoenix mission, the Spirit and Opportunity Mars rovers, as well as Dawn, GLAST, and the Themis missions. On December 1st, 2006, he became a part of the United Launch Alliance, where he continues to work in the NASA Customer Program Office to successfully launch critical NASA payloads. So please welcome Dr. Scott N.A.S.A.
Thank you very much, and on behalf of the United Launch Alliance and its 3,700 men and women, I'd like to welcome you to the launch of the GRAIL spacecraft tomorrow, hopefully. Next chart. So as Amanda mentioned, the NASA team chose the highly reliable Delta II vehicle to launch the GRAIL mission. The specific configuration they've chosen is, we call it 7920 Heavy. Delta II has been a very successful, probably the most successful launch vehicle still flying today. In fact, just to let you know, it's flown 94 times successfully consecutive prior to today, so I hope that tomorrow will be 95, and we have great confidence in that. The vehicle is made up of 4 major components. I just point out here, this is a first stage. It's made up of a lot of big fuel tank here, so this is where I take credit earlier for we can spend a lot more than 29 gallons of gas or fuel to get to Mars or to the moon. So the first stage, 2 big fuel tanks, the RS-27 engine down here. We also have 9 solid rocket motors that will ignite and be part of getting us going there. We have the second stage in this case, and then the fairing out here, which protects the spacecraft as it goes through the orbit, or goes through the atmosphere. And so just to kind of give you a feel, the fairing, when you drive in your car, if you were to roll down the window, your hair would blow, or you stick your hand out, you'd feel that pressure. So the fairing protects the spacecraft until there's no more of that. So if you were riding on the spacecraft, or if you were on the GRAIL spacecraft, and once that fairing separates, you wouldn't feel any kind of pressure, any kind of blowing, your hair wouldn't get messed up or anything like that. So that's what the purpose of the fairing is to protect the spacecraft as we go up through the atmosphere. Okay, next chart. So this is just a quick graphic of how all the things come together. I won't spend a lot of time on this. If you go on the tour, you may see some of these items. You see the 4 different areas here. This is where the spacecraft processes over at Astrotech. Then we've got a booster processing facility to process the second stage here, run it through all sorts of tests, as well as look at the GEM motors come together. That all comes together out of the spacecraft, or out of the launch pad on Slick 17. Next chart. This kind of just shows you where Slick 17 is in relationship to the Cape. Most of the buildings that you saw, we receive and inspect over here, and of course the spacecraft is processed over here. The viewing site that you'll be looking from is right here. As Amanda mentioned, kind of got a pretty good shot straight across to 17. Next chart. So this is what it'll look like tonight if you go out. It'll be dark, but if you go out for the photo opportunity. And just wanted to point out, this is what we call a mobile servicing tower. It's a building on wheels, and it moves back and forth as we work on the spacecraft. The tower is pulled up, and it gets used for a lot of things. So the next chart shows kind of how it all comes together. So in this first picture here, you can see the mobile servicing tower has been backed away from the pad. The first stage comes out horizontal. It then gets lifted up by the crane, as you see here, and then the mobile servicing tower drives over, sets the vehicle down on a pad. Next couple of pictures here show solid rocket motors, same kind of a thing. We lift 3 of those at a time and roll them over, hook them to the vehicle. Here you see the second stage being lifted, fairing going up. This picture shows the spacecraft itself. As we bring the spacecraft from Astrotech, it's canned up so that we can maintain cleanliness, air conditioning, and all of those kind of environmental requirements. You've seen this picture of the 2 spacecraft sitting inside the fairing, and then hopefully tomorrow morning we'll see this similar kind of scene. Next chart. I'm going to skip this one since we've seen it a couple of different times as the spacecraft sit in the fairing. Go ahead. So this is just a quick little graphic that shows all of the events and how they happen. And I'm going to do this slightly different here. So if we can skip forward to the video, please. So go forward 2 charts and then play the video. Thank you. So we're going to see some live footage here as we lift off up through second stage. Second stage actually has 2 different burns that it does. So we'll see the ignition of the first stage engine and the 6 of the ground, or 6 of the gem motors. At liftoff, we'll have about 1.3 million pounds of thrust lifting up using that fuel that we talked about earlier. Here you see the separation of the first 6 motors, the other 3 light. They burn for another 80 seconds, and they're separated. At about 4.5 minutes into the flight, we'll burn out all of the fuel in the main engine, and we'll separate the main engine from the second stage. As I mentioned earlier, the second stage has 2 basic ignitions here. So you see the first one, and as part of that, during that first burn of the second stage, you see the fairing separate and pull away. So after that point, after the first burn of that second stage, we're going to be going about 16,000 miles an hour, and we're going to coast for about almost an hour, about 58 minutes. Then we're going to start the second stage again. We'll burn for about 4 or 4.5 minutes, and then 9 minutes later we'll separate GRAIL A, and just a few minutes over, a little bit over 8 minutes, 8 minutes 15 seconds, I think we're going to separate GRAIL B. And that's all going to take about an hour and a half to happen from the time we launch in the morning. Okay, so go back a couple of charts now to the ground trace. Forward 1. All right, so this is just how it's going to happen. Looking down, you can see number 1 and number 2. These are we're going to burn out the first stage engine, second stage engine, and then you see this big long coast, almost halfway around the world, or even a little bit more. We'll ignite the second stage a second time, burn it, coast for 9 minutes, drop off GRAIL A, drop off GRAIL B, just right over the west coast, if you will. All right, now let's go to the last one. So again, Amanda had most of this stuff about 12 o'clock tonight. We'll roll back the tower. We'll have terminal count will begin just a few minutes before 6, and hopefully at 8:37:06 we'll lift off. If not then, we'll try for the 9:16, 12 launch slot as well. And thank you again, welcome, and go Delta, go GRAIL.
I should mention we have some moon rocks you can see and touch over in the IMAX theater, so if you want to touch a piece of the moon while you're here, you can do that. This concludes our briefing. I'd